So, this lesson, we are looking into integration by parts 11.6, 11, whoops, 11.6, 11, oh, where, what happened? 11.6. So we're looking at 11.6, integration by parts. Remember, a few lessons ago, I've asked you to write down RT in here. We can continue to fill up this word RT, the next one is S, and then P. Now, this is the order that we do integration. When you see a question, you know what to do, we can follow this thinking method called RTSP. R stands for reverse chain rule, which is always your first protocol when it comes to integrating an expression. Okay, if you don't know what to do, first thing you should consider is reversion. Of course, revision. Reverse chain rule. Jesus. Reverse chain rule. And then T stands for trig identities, RTSPS. Can you guess? We have done this last lesson, which is substitution. And then the last one is by parts, and hence the word P, by parts, RTSP. So reverse chain rule, trig identities, substitution, and by parts. But of course, if you can use a formula booklet, the formula booklet will overrule everything in here. Okay, but usually we use RTSP when we can't use formula booklet, obviously. So RTSP. So we finally look at the last one, which is called reverse integration by parts, which is sort of the last one that you have to know. It's the big trick, big technique in integration that you have to know. 11.7, 11.7, and 7.5, they are not as important, but they are a bit easier to apply because they're not new skills. You just have to do something extra. But this one is a new skill. So let's have a look. Integration by parts, today's lesson. So what's integration by parts? Okay, integration by parts helps you to integrate a product. It's like the opposite of product rule, but it's not exactly the same. It's not the same. It's not the same relationship where we have chain rule and reverse chain rule. It's not the same. It's in opposite sense in that way, in sense that we are integrating a product. Where product will help you differentiate a product, but integration by parts help you to integrate a product. So, for example, X times cos X, then we can use integration by parts. Now, integration by parts is a formula. You don't have to remember it because this is given in the formula booklet. It's weird. Now, this is the formula. It is weird, I know. But I think as you do higher level of maths, you see more and more weird things. Anyway, so there's a formula. So what is this? U dv and dx by dx. So essentially, this means, okay, this is the one term, this is one term, this is another term. I'll show you how it works. Okay, now before we do that, we have in here, write down the rule stand for ILATE. So ILATE rule. ILATE. So ILATE. I stand for inverse trig. So stand for, let's say, arc sine, arc cos, etc. L stand for logs and logarithms. E.g., we've got ln, we've got log, etc. A stand for algebraic functions. So anything like, for example, x squared, x cubed, square root of x plus 1, etc. These are algebraic functions. T stand for trig. Let's say we've got sine 3x, sec 3x, etc. And then E stand for exponentials. For example, we have e to the power of x, e to the power of x squared, 3 to the power of x, etc. So what does this rule do? This rule tells you the order to choose U. Now I'll explain this rule, okay, using an example. Just write down first ILATE rule. We're going to follow this ILATE rule using by parts. So when it comes to by parts, you have to remember this ILATE rule. Now, so if I can, let me pop up this. So, okay, so remember ILATE rule. Okay, so ILATE rule, we're going to next. Okay, example, we're going to do x cos x, x times cos x dx, integrate that. So let me copy this formula again. Now, to use ILATE rule, if you sort of, sorry, to use integration by parts, you can sort of compare, this is the question, okay, so this is the question, this is the question part, this is the question. So this is a question function. We need to know, if you look at the left-hand side of the function, how the formula works is u is one term, okay, one function, and then dv by dx is another. The question is, which one do you let u, which one is dv by dx? We can use the Eilert rule, okay? So in the Eilert rule, you see in here, you've got x and cos x. So x belongs to algebra, so that's A. Cos x belongs to trig, so that's T. Now you can see A comes before T in the Eilert rule. Therefore, A, the x term, will be the u. So we'll let u to be x. And then the other one, we have to let it to be dv by dx. Because that's how the formula works. The formula tells you we have to let one to be u and let the other one to be dv by dx. Because of the, I'll explain again, because of the Eilert rule, whichever letter comes first will be the u term. Okay, the order to choose u. So the u is the algebra term, which is A, which is x, and T is a trig, which is cos x. Now this will belong to dv by dx. Okay, next, I'm going to differentiate, find a counterpart of each term. Du by dx, differentiate x is 1. Next, let me do here, I'll differentiate. Okay. This one, to find v, I need to integrate because it was given as dv by dx, so I need to integrate. So integrate cos x is sin x. We don't have to do a plus c in here, okay? Then we can use the formula, okay? So I'll copy the formula again. The formula is the integral of u dv by dx, which is left-hand side, the question. So the question is integral of x cos x dx equals, now let's follow the formula on the right-hand side, okay? U is x. Don't tell the English teacher, u is x. V is sin x. So uv, now put a bracket. I usually put a bracket when I multiply two different terms, just in case, you know, I multiply some negatives or some, some more than one times in a bracket. Then I always put a bracket anyway. Minus the integral v sin x times dv over dx times, I'll put a bracket here, times dv over dx, which not dv over dx, times du over dx times du over dx, which is 1 dx. So that's how we rewrite the formula. Okay, so uv minus integral v du by dx. That's the formula. Yep, that's how we apply integration by parts. So we've applied the formula. We've applied the formula. Is that all? No, not quite, because the formula has an integral in there. So we're going to rewrite this is x sin x minus integral of sin x dx. So the question becomes a lot easier to integrate because rather than integrating x cos x, you're just integrating sin x. Now, which is not always the case, but using by parts does help you to break down the original function into something else, which is a lot more easier to integrate, or something you can recognize to integrate. So x sin x left-hand side minus the integrate sin x, which is negative cos x. Now we put a plus c. Now, note, I did not do the minus in one go. It's just me breaking down the process. So I put a minus in the front, okay? I ignore the minus, I just leave the minus outside. And then I integrate sin x separately as minus cos x. Then I deal with the minus. Minus makes a plus, so it'll be x sin x plus cos x plus c. Remember, our brain can only handle certain things, a few things. We cannot handle too many. We're not like computers. We can only handle certain things in one go. So in here, by me not working at the minus, if you can work on the minus in one go, yes, you can. But here, I'm just sort of showing you step by step what do we do. So x sin x plus cos x plus c. That's how we use by parts. First, use Eilert rule, determine which one is u term, and then the other will be dv by dx. Then we du by dx, we differentiate, find the counterparts of each side, du by dx. This one, we have to do a small integration. Then we apply the formula. So uv, so choose the right thing, minus v du by dx. Okay, so I can mix and match the sweets. Choose the right thing, and then you just simplify n plus c. Okay, right, next one. Okay, we use the Eilert rule again. So Eilert rule in here, Eilert rule. Now look at this, x squared times ln x. X squared is algebra A. Ln x is L. L comes before A in the Eilert rule, okay, not in English, but in the Eilert rule. So we're going to let U to be the L term, which is the ln x. And dv by dx equals x squared. Now, why we choose this, I'll let you write the reason next to it. If you need to write the reason, why do we choose U as ln x? You write down, okay, it's a small note to yourself. Why is U ln x, but not x squared? Okay. Next, we need to find a counterpart, so du by dx. Du by dx is differentiate ln x is 1 over x. Integrate x squared is x cubed over 3. Can you guess what's a common mistake student makes from the first step to the next step in here? Yes, a lot of students would have differentiated in here from dv by dx to v to differentiate again, but actually this one you have to integrate. So just be mindful of that. Right, next we can use the formula. Okay, so we can use the formula. I'll just copy and paste the formula again. So here's the formula. The question was integral of x squared. Now, do you write the left-hand side? Do you write the left-hand side? Because later on, we might need to use the left-hand side. So write left-hand side, which is a question. Right-hand side, uv, u ln x times v, pull a bracket, times v, pull a bracket, x cubed over 3. Okay. Now, what happens if I don't pull a bracket? Okay, if I don't pull a bracket, let's say if I don't put this wrong. Okay, if I don't pull a bracket, you might be thinking, oh, I can simplify to ln x to the power 4 over 3 in here, which you can't, because this x cubed over 3, you're not ln in the x cubed over 3. So x cubed over 3 is not part of the ln, so you can't do that. That's why hence the importance of the brackets. Okay, so put a bracket. Next, minus integral v x cubed over 3 times du by dx times 1 over x dx. So we apply a formula. We usually write the ln term at the back of each term, so I'll rearrange x cubed over 3 ln x. Okay, that's a lot better to see visually. Minus, I can see inside this bracket, this can be simplified. So x squared, so it becomes integral of x squared over 3 dx equals x cubed over 3 ln x minus, integrate this, quite simple, add 1 to the power, becomes 3, divide by new term, divide by new power, 3, so it'll be x cubed over 9 plus c. That's the final answer. Then that's the final answer. Right. Next, sometimes you might have to do IBP twice. Well, how do we do that? Well, let's do the same thing. Eilert rule. Okay, maybe you can pause the video and decide which one is u, okay, and what is dv by dx. I'll let you do that. Try that. Okay. So in here, x squared is algebra, e is exponential. So a comes before e, so a is x squared, and dv by dx is e to the power of x. Remember, we choose whichever letter comes first as a u. Then as you do du by dx, which is 2x, I need to find the integral of e to the power of x. Integrate e to the power of x is just e to the power of x. Next, I can use a formula. The formula is, I know, you lazy people, I'm going to paste it for you again, so you don't have to go back and forth and find the formula. Remember, this formula is given in formula booklet. It's given in formula booklet, page 6 or page 7, I can't remember. So the question was left-hand side, x squared. Do you write the left-hand side? Remember, do you write the left-hand side? Equals uv. So the formula tells me to write the left-hand side, which is a question, then equal uv. U is x squared, put a bracket. V is e to the power of x, put a bracket, minus the integral, put a bracket, v times du by dx, dx. Okay. Next, the first term, we can't do anything. And the second term in here, if I can take a 2 out, integral of x e to the power of x dx. Now, in here, how do we integrate this? Well, this is another product. So we have to do another integration by parts. And hence the example here, IBP means integration by parts twice. Now, how do we know we can do integration by parts twice? Well, this integral is not same as the question. It's not same as the question. Therefore, it means there is progress. Even though a little progress from x squared e to the power of x to x e to the power of x, but there's no square. So there is progress, okay? Even though, you know, as small, as little as, you know, just small. So then we can do IBP again. Okay, so IBP again. So in here, I'll do IBP again. Okay, so let's do the Eilert rule again. Eilert rule. This time we've got A algebra and E exponential again. So U in here will be X, and dV by dx will be e to the power of X. Let's do that. Du by dx, differentiate X is 1. dV, V integrate e to the power of X is just e to the power of X. So we can use the Eilert rule, use the by parts again. So the left-hand side is integral of X e to the power of X dx equals to, you remember the formula? uv minus integral of V times du by dx. So which leaves us as X e to the power of X minus integral of e to the power of X dx. And we know the integral of e to the power of X, don't we? Which is simply e to the power of X, and then we have plus C. I reckon we can ignore the plus C for now because we have to put it back to the original function. So after we've done that, so this X e to the power of X term, we can replace it. So next step here, it was X squared e to the power of X minus 2, and then the integral, so I'll put a bracket, X e to the power of X negative e to the power of X, and then we could put a plus C at the end in here. So expand bracket minus 2x e to the power of X plus 2 e to the power of X plus C. Hence the importance of a bracket, because if you don't put a bracket, you will forget a minus, which makes a plus in here. All right, so this is how we do integration by parts twice. We see a product, so we use integration by parts, and then we use the Eilert rule. We'll do it normally, like the previous examples. But in here, once we use the formula, we realize there is another product. So you write down, okay, another product. Why? Well, if you have to explain to yourself, why IBP again? Okay, it's all about why. Well, why? Because we see another product, and this product is not the same as a question, so we can do IBP again. Now, if this function is the same as the question, please refer to the special case later, which I'll give you a special trick. But we know this term is not the same as the question, so we can do IBP again. If it is the same as the question, we can't do it again because it means you're going in a loop. Imagine that's the same. You do IBP again, you end up in a loop. Therefore, as long as this function is not the same as a question and you see a product, IBP again. Now, sometimes you might have to use reverse chain rule after using IBP in this function. So therefore, RTSP. Okay, you see a product, therefore by parts, because reverse chain rule doesn't work in here. So you have to be flexible in terms of using the correct skill in integration. RTSP, reverse chain rule, trig identities, substitution, and by parts. In here, we can't use reverse chain rule, we can't use trig, we can't use substitution. Maybe you can, but it's the easiest way to do integration by parts because you see a product. Okay, once you've done IBP again, you've done it in here, you realize this could be integrated easily, so you integrate it, and then you put it back in the original function with a bracket, expand a bracket, and there's your answer. Okay, so here you go. Here's a question for you to try. Pause the video, have a go at the question. You might need to do double integration by parts twice. I'll let you decide. Have a go. Okay, when you're ready for the answer, you can press play. Right, here's the final answer. Negative x squared cos x plus 2x sin x plus 2 cos x plus c. Don't forget the child. If you got it right, well done. Move on. Okay, listen to the next one where we're integrating with finite integral of ln x. But if you got it wrong, let's go through why. First of all, again, Eilert rule. We've got x squared, which is algebra. We've got sin x, which is trig. A comes before trig, so we're gonna let u to be x squared. And the other one will be dv by dx. dv by dx is sin x. So let's differentiate du by dx, which is 2x. Integrate that one. Integrate sin x is negative cos x. Don't forget negative. Remember the sine cos clock, integrating sin x is negative cos x. Then we can use the formula. So the formula tells me to write the question again. Integral of x squared sin x dx equals uv. U bracket v negative cos x. Now what happens if I don't put a bracket? If I don't put a bracket, it becomes x squared minus cos x. Hence the importance of the brackets, okay? I like to catch up with the chicken nuggets. Minus integral of v on the bracket, du by dx, v du by dx, dx. I'm going to simplify things a little bit first. For example, pulling the negative out, we're writing it. So negative x squared cos x, rearrange it, just like decluttering your desk, make it a bit neater so you can revise better for your brain to process, which is true. If your desk is very messy, your brain actually will, you distract your brain to actually think about aware of things, left and right. It just declutter, it's just making your brain doesn't function as good as it could, efficient as it could be. Next one, I see a minus, which makes a plus. I can take a 2 out. So plus 2 integral x cos x. Oops. It's like I'm going on a calligraphy course. X cos x dx. Next, my focus is now on how to integrate this. Well, I realized this is not same as a question because the question was x squared sine x. But I see a product. So I think about, okay, RTSP, reverse chain rule. Doesn't quite work in here because if I let y, hopefully you remember what reverse chain rule is. If you try to do reverse chain rule, think about y as sine x. If you differentiate that, there wouldn't be an x coming out. So we know reverse chain rule doesn't work. And we know trig identity doesn't work either. It doesn't work on terms without powers, basically, with the identities. Not substitution, so by parts, because it's a product. So IBP again. Okay, IBP again. We'll let u, this time is x, and dv by dx equals cos x. Now, at any point, if you were stuck in any lines and you realize I've gone through that already, you can pause the video and carry on working and then come back to this video again. You don't have to listen to the whole explanation. That's hence the benefit of using a video in here. We can differentiate du by dx, which is 1. Next, we can integrate cos x is sine x. Right? Now, don't ask me why u is x. If you do have to, isolate rule. Okay, isolate rule. Next one, we can rewrite the question using a formula x cos x equals uv minus integral of v du by dx. So, which is x sine x. Integrate sine x. There's a minus in front, so I'll keep a minus in front. Ignore the minus, okay? Integrate sine x is negative cos x plus c. Well, if you want to put plus c or not, it's not really a big thing. So x sine x plus cos x. Probably ignore the plus c in here because I need to do a plus c in the original function anyway in the main line. So I would do the plus c in here. So I've done it. So I can now rewrite as equals to negative x squared cos x plus 2 bracket x sine x plus cos x, and I can do a plus c in here. So therefore, my answer will be negative x squared cos x plus 2 sine x plus 2 cos x plus c. Okay. Right. Yes, this lesson is going to go on. 2 more examples, which are different, one of a kind. Example, integrating ln x with finite integral. 2 things you're going to learn in here. 1, you're going to learn how to integrate with a finite integral using by parts. And 2, how to integrate ln x. You have learned how to differentiate ln x. The derivative of ln x is 1 over x. But when you integrate, 1 over x is ln x. But actually, you have never learned how to integrate ln x. And here's the solution. Okay, we'll ignore the finite integral for now. Okay, here's the solution to this. First, this is an integration by parts. It's a hidden one, but you have to know, you have to understand. Now, sir, there is no product. How do we use integration by parts? What we can do is we can think about as 1 times ln x. Now, this doesn't work on all other functions. Only works for ln x for now. Okay, so you'll be thinking, okay, I integration by parts. I use isolate rule. Where does the 1 fit in terms of isolate? It doesn't. So we're going to make a random guess. Okay, I'm going to make u as ln as u. U as 1. Let's say. Okay, do you not write anything yet? So dv by dx surely will be ln x. Now I'll do du by dx. I know that's 0. Now what about this one? You have to integrate ln x, then I'm just repeating the question, isn't it? Therefore, I know this is wrong. Okay, so I know this is wrong. And that's your cue knowing u is 1 won't work. So you have to switch these two over. You have to do u as ln x and dv by dx as 1. Because differentiate ln x, we know, which is 1 over x, integrating 1 is x. So I'll say again, you don't know which one. Yes, Eilert rule doesn't apply in here. But if you try let u to be 1, you realize you'll hit a dead end because you'll be just repeating the question. That's how you know you have to flip it over as u as ln x dv by dx equals 1. So I can use the formula. So the integral 1 to 2 ln x dx equals v at uv minus the integral of v du by dx 1 and 2 as a big bracket in here. We can't apply the 1 and 2 yet because we still got an integral inside the square bracket. So I'm going to put x ln x. We write it a bit neater. Minus, oh, lovely, x times 1 over x simplify into 1. Integrate 1 is x. I think that's the best thing you can hope for at integration. An easy and nice expression to integrate. There's nothing scarier than looking at a monstrous expression not knowing how to integrate. If you got 1, you feel like you've been spoiled. So then we can now apply the 2 and the 1. So we can put the 2 in, 2 ln 2 minus 2 as a bracket, subtract, put it as a bracket, 1 ln 1 minus 1. Another one looks like L, so I'm going to put it. I don't normally write a 1 like this, only when I confuse myself as an L. So 2, and no one likes an L. 1 ln 1. ln 1 is 0. Minus 1 is plus 1. A lot of students would have forgot the plus 1 in here. So it'll be 2 ln 2 minus 1. Final answer. Okay. Right, so explain again. This hidden one, we have to use integration by parts, where you have to use 1 times ln x. 1 times ln x. So, yep, so 1 times ln x, where you have to let u to be ln x, and then dv by dx equals 1. Okay? Right. Last but not least, one of a kind. Use integration by parts to integrate e to the power of x ln x, e to the power of x sine x. Now, can I ask you to pause the video, have a go, and try to use integration by parts to integrate that one, okay? And then up to the point where I would like to see when you integrate 1 time, okay, you should get e to the power of x cos x. I'll show you the steps in between, but I want you to go to this step once you apply the integration by parts. Okay, I want you to stop there once you got to this point. Okay, pause the video, have a go at the question when you're ready, or when you've got this step, or if you've got stuck, you can play the video. So you should get up to this step, e to the power of x cos x, but that's not quite the same yet. So you can do IBP again, okay? IBP again. If you got stuck in here, carry on, pause the video, and carry on again. Right, so once you do IBP again, you let u is cos x dv by dx equals e to the power of x. You differentiate, okay, get negative sine x and integrand here, and do IBP again, you should get e to the power of x cos x plus integral of e to the power of x sine x dx, which is what we told in the beginning. But what I've forgotten is the previous part. So I rewrite that as using a black pen. That means using the original function. I rewrite that e to the power of x sine x minus the integral of e to the power of x cos x, which is what we've got from the IBP in here. So replace it. So the question is, can I do IBP again in here? Answer is no. Well, why? Because it's the same as the left-hand side. So then what it means is if you have the IBP again, you have to repeat all this process again, which is at that end, you're going in a loop. So this is special trick. Only works in here. Okay, so it's a special food in the menu. You know, sometimes we go to a restaurant, if you know a restaurant so well that they've got a hidden menu which you don't know. Okay, so this one, what do we do? Now do write down, okay? If the left-hand side, okay, equals a function on the right-hand side, what we can do is we can rearrange both to the left-hand side. Well, how? Remember, so imagine that's a minus, you add it to the left-hand side, becomes a plus. becomes a plus. So then what we have is imagine that's a y function here, y and minus 1 on the right side. If you put a minus 1, it becomes 2y. It becomes 2 lots of integral of e to the power x sine x dx, which is e to the power x sine x minus e to the power x cos x. Then all I need is the integral, so I can divide the 2 over. So this is a special trait, divide by 2 over, so it becomes e to the power x sine x minus I've got plus c, e to the power x cos x over 2 plus x. So that's the final answer. Special trait again. If you realize you're going in a loop, okay, then you have to bring it left hand side, make it 2 lots, and then divide 2 over. Okay, and that's the end of integration by parts.